So last week, I got started working on doing the graphs of trig functions. So I wanted to do a few videos in case you were unable to attend those sessions. Before I really get into graphing the trig functions, and what I mean by that is we're going to wind up doing graphs, like regular coordinate plane type graphs of these trig functions, okay? For instance, in a little bit, we're going to do the graph of y equals cosine of x, okay? And before we do that, though, I'm going to go back to the unit circle and just remind you of a few things that are going to be important, okay? So we've been looking at the measures of angles, okay? And so, for instance, if this right here, that's an angle that's 30 degrees. The amount of rotation was 30 degrees, okay? And then after we talked a little bit about degrees, we talked about radians. And radians, a good way to think about that is that the measure of the angle in radians would be the length of this arc if you're on a unit circle. So if the radius is 1 unit, like it is for this picture, then the length of this intercepted arc would be the measure of the angle in radians. So that's kind of the way to think of where the pi over 6 came from. And then 30 degrees is like the amount of rotation there, okay? Now, so if you're on a unit circle and you are dealing with the angle in radians, then that's actually, I know it helps to think of it as a degree, but it's actually just a real number. It's just pi, which is about 3.14 divided by 6. So it's some real number, which enables us to do a graph using two real number lines. Okay, so these are just number lines where, you know, pi is about 3.14 and pi over 2 is half that. So that's how we can make that jump from the unit circle to the coordinate graph, is by using radians, which are really just real numbers. Okay, now here's another thing that you need to remember. Remember how if you're on a unit circle, so on a unit circle, the first coordinate is going to give you the cosine of the angle. So that would be the cosine of 30. And the second coordinate, okay, gives you the sine of the angle. And that's true if you're on a unit circle. So you know the cosine and the sine of the angle. Okay, so here's what we're going to wind up doing. We're going to wind up thinking about the x-axis here. I want you to think about where this x-axis comes from. So here's the x-axis down here. When you're thinking about that, the x-axis is what you do the cosine of. The x-axis is the x's are your inputs. Even though they're just real numbers, it helps to remember or to think of them like they're the angles, okay? So the x-axis is like the angles. Then the y-axis is the value of the trig function at that angle. So the y-axis will be where we put the value of the cosine of those angles, okay? All right, now, where did this x-axis come from and how is it connected to the unit circle? So I need the bigger one for you to see it. But see the 0, the pi over 2, the pi, the 3 pi over 2? It's like if I took this right here from 0 to 2 pi and I made a circle out of that. So I brought it around, you know, and formed a circle out of it. Okay, that is where this unit circle comes from, okay? The 0 that you see here is actually right there on the unit circle, not in the center, not the center of the circle. That pi over 2 you see right here actually is up there, okay? This pi is where it would wind up being over here, okay? And then the 3 pi over 2, okay, that would wind up being down here, okay? And then the 5 pi over 2, that's actually going to, I don't think I did those right. The 3 pi over 2 is down here. The 2 pi would be here, and then 5 pi over 2 is actually around back there. All right, now this isn't quite to scale. In fact, let me see if I can make this stretched out a little bit so it looks more like it should. So I want the y-axis to stay about the same. But the x, the spots on the x, it's like this length right here, this piece should be that piece unwrapped, okay? And then from here to here, that's this piece unwrapped, okay? So that looks a little better size-wise. Okay. Now, what's going to be important to be able to get the graph of the cosine is for you to think about the value of the cosine at a few of these points and kind of think about what happens. And so the x is like your angle, the y is where we'll put the value of the cosine at that angle. So one of the things to remember is how the points on the unit circle give you the cosine and also the sine. And when you're here at 0 degrees, that's the ordered pair 1, 0. When you're at pi over 2 up here, that's the ordered pair 0, 1. Over at pi, the quadrantal angle, the coordinates of that quadrantal angle would be -1, 0. And then here, you'd be at 0, -1. Of course, there's all kinds of stuff in between as well, right? But that'll help us get started on this. So if we're going to do the cosine of 0, and we're going to put its location on here, cosine is the first coordinate. So you should be thinking this. You should be thinking, okay, so when I'm at 0 degrees, which means I'm just right here, the cosine is 1. Okay. When I'm at pi over 2, which is here, the cosine is 0. When I'm at pi, the cosine is -1. When I'm at 3 pi over 2, the cosine is back to 0. When I'm at 2 pi, that means I've gone a full rotation. I'm back here. The cosine would be back at 1. And you see, when we get to 5 pi over 2, we're just wrapping around that circle again. So 5 pi over 2 winds up being the same as pi over 2, right? So we're back at 0. And you see I'm going to have this pattern kind of emerging for the cosine, okay? And you can even think about it this way. If I did negative pi over 2, that means I'm down here. I went clockwise pi over 2, and the cosine would be 0. If I went to negative pi, I would be at -1. And if I went to -3 pi over 2, I'd be back up here. I'd be at 0. So the cosine graph seems to go up and down, up and down, up and down. Trig graphs are what we call periodic. Okay, they have like a repetitive nature to them. They're really good to model things like temperature, tides, things that kind of keep repeating over time, kind of fluctuating, but having a pattern that repeats over time. Okay, so now the thing is, when we connect this, we don't want to connect it with a bunch of straight line segments. So you have to think a little bit about, well, what happens kind of in between these two things. So like, let's say you're here, which is pi over 4. Let's add a pi over 4 in there. Well, the cosine of pi over 4, that's square root of 2 over 2. Okay, so when I think about that, I actually want the value of that. I'm going to do the square root of 2 divided by 2, and I get the decimal 0.71 about. So when I'm at pi over 4, I'm not at halfway. It's not going to be a straight line. I'm at 0.71. So I'm like right up here, okay? All right, so we could go in and we could take all the x coordinates of all the in-between points and put them on here as well to kind of flesh out what it looks like. It's not going to be straight line segments. It's going to have a little curve to it. It's going to go like that. And then it's going to come down here. And then it's going to come back up. Okay. And then it's going to go back down. And so on, okay? And it does the same thing this way. All right, and comes back here, goes back up, and this just continues. All right, now what I want you to do in a minute, we're going to be making kind of a library of the trig graphs, and then learning of the basic trig graphs, and then learning what to do when we're not just doing cosine of x, but we're doing cosine of some expression more complicated than that. But this is what I wanted to do to start with. And I want you on this one just to see how, yes, these are the x coordinates, but they're not the x, this x, okay? Here, the x is really like the angle, like the theta. And when I'm trying to graph y equals cosine x, what I put on the y-axis is the value of the cosine. So it goes as the y, goes as the vertical distance, even though it's the x coordinate. I think that's the hardest thing for students sometimes. And remember what we did is it's like we took this circle and we just cut it right here and unwrapped it. So this spot right here is the spot on the unit circle, okay? And the value of the cosine at that spot is 1. And then this spot corresponds with pi over 2. And this spot corresponds with pi, okay? And this spot corresponds with 3 pi over 2, and so on. And then what we're doing is looking at what is the cosine at those locations. But it's almost like I just took this like a piece of string and then laid it out right here. And so I have my pi over 2, my pi. Get rid of that ordered pair right there. Okay, so it's like I took that piece of string all the way around here, cut it, and just stretched it out right here. Okay, so the end of it is here. And then I just stretched it out and marked, well, where would pi over 2 show up? Where would pi be? Where would 3 pi over 2 show up? Where would 2 pi be? And then I looked at making a regular coordinate graph where I'm plotting what the cosine would be at each of those locations. Okay? All right, so let's do one more of these. Let's go down and look at y equals sine x. So similar concept of how it's developed. Okay, let me stretch this out a little bit like I did the other one horizontally. All right, and then I'm going to be trying to do y equals sine of x. And x really is a real number. Okay, so this is my x-axis. It's really a real number, but it helps, I think, to think of it as that's where the angle would have been. And then the y-axis, the y values would be the sine of that angle. So again, it's going to be important to keep in mind the coordinates of the ordered pairs for these quadrantal angles. There. Okay. All right. So when we go about trying to graph y equals sine x, this spot is here. Pi over 2 is there, and I've unwrapped it. Here it is when I stretch out that string around here. Okay. Pi over 2 shows up right here, and sine is the y coordinate. So the sine would be 1. When I'm at that starting point, notice the sine would be 0. So when you've got 0 degrees, the sine of 0 is 0. Okay. Sine of pi over 2, I can tell, is 1. When I get to pi, I'm over to here. That would have unwrapped to be here, and the sine is the y coordinate, so I'm back to 0. 3 pi over 2, remember to look at the y coordinate. The sine of 3 pi over 2 is -1. The sine of 2 pi is back at 0. 5 pi over 2 starts over again, starts back around, and you're at the same spot you were with pi over 2. So you'll start seeing that repeated. And then you can do the same thing we did before. Think about going in the negative direction, going clockwise, and you see that negative pi over 2 would have a sine of -1. Negative pi is back at 0. Negative 3 pi over 2 is really back here. It's all the way around to there. So it would have a sine of 1. So you get that same periodic nature, but you want to kind of contrast this with cosine. And the best way to do it is just to pay attention to the coordinates of the quadrantal angles. That's a really good way to distinguish the two. So, and if I did all the in-between points, it wouldn't be a straight line. It would curve up until it hits that. Then it would curve until it hits there. Then it would turn around like so and keep going. And the same would be this way. Okay, so it's what we call periodic. Okay, so it's like that section of this graph from here to here just gets repeated, right? Can you see it? It's kind of, I went a little further on this one. Okay, here's that section again. Here's that same section. Up, down, back to 0. Okay, then there's another section. And then this would keep going like that. Up, down, back to 0. And it would keep going like that. So that section right there is what gets repeated over and over again. So the sine graph, this portion right there, that's the period, the part of the graph that's getting repeated. And the period is 2 pi. So every 2 pi, you got the same thing being produced. Okay. All right, let's back up a minute, look at cosine and think about that. Well, we can say the same thing about cosine, can't we? If you consider it from here to here, if you imagine this continuing, you know, wouldn't that have just done the same thing? It would have gone up and then hit 0 and gone down. So if you look at that, get out here to negative 2 pi, and I cut it, I'd have those same sections happening. Every 2 pi, I'd wind up getting the same picture happening. So the period for this is 2 pi. You got the same thing happening every 2 pi chunk. Just gets copied and pasted over and over and over again. All right, another thing that's the period. So the period of cosine is 2 pi, just like the period of sine was 2 pi. All right, another thing we could comment on is look at how it fluctuates. See how it just keeps going up and down, but see how the biggest value of cosine is positive 1, and then it gets smaller and smaller and smaller until it gets to negative 1, and then it starts getting bigger and bigger and bigger until it gets to 1. Okay, so if we thought about that, we could think about the domain and range. The domain would be any real number. Okay, you might say that if you were doing interval notation. The range only turns out to be numbers between negative 1 and 1. By the way, that's why if you try to do sine inverse of a number bigger than 1, remember how that happened when you were doing your law of sines and cosines? If you get that, remember how it gives you an error? Because that's not possible. It's not possible to have a sine that's bigger than 1. Okay, it's not possible. All right, so that's for cosine. The domain is from negative infinity to infinity. The range is just fluctuating back and forth between negative 1 and 1. Okay, let's look at this one. Hey, that looks the same. The domain is also from negative to positive infinity, and your range also fluctuates from negative 1 to 1. All right, but kind of keep in mind or be able to figure out so that you can get straight which one's which, how the sine function starts at 0 because the y-coordinate is 0, and how the cosine function starts at 1. The y-intercept is 1, and that's because when you're here, that point is 1, 0, so the cosine would be 1. So cosine has a y-intercept of 1. Okay. The y-intercept is the ordered pair 0, 1. And then with sine, the y-intercept is 0, 0. Okay. All right, so I'm going to stop that. I wanted you in this video to just begin to kind of see how we can, in a way, cut this string that's around the unit circle and stretch it out over here. That's what this is right here. And we can take the sine values, the y-coordinates of all of the angles around that, and that's what determines what the picture for the graph of y equals sine x would look like. Same with cosine. Just unwrap the unit circle and stretch it out. Here's where I would stretch it out. And then those are the key quadrantal angles. And what I'm going to do is just use the cosine of those and plot where the cosine would be located. And that's what determines what it looks like. So these trig graphs are what we call periodic. The functions themselves are periodic functions because you got a certain chunk of it that just gets repeated over and over and over again.